A huge benefit to delegates is that it supports multicast delegates out of the box. This means that you could construct a chain of delegates that will be sequentially executed when you invoke the referenced delegate. Let's say that you define 3 methods that all correspond with the process completed delegate. To keep it simple, use an expression-bodied member and simply print something to the console. This to understand the execution order. We can name them 1, 2, and 3. How could we indicate that we want all of these methods executed in a chain whenever process completed is invoked? This is where we want to construct something known as a multicast delegate. Start off by specifying that you want to create a process completed delegate. As you've seen previously, you can use this like any normal variable. Since the delegate is declared inside the scope of the order processor, if you want to explicitly use this type, you can write order processor dot process completed. Call this local variable chain. The first method we are going to reference in our chain of delegates will be the first method called 1. This just looks like a normal instantiation of a delegate variable. How is this different from what we've done before? So far, there's no difference. We've just pointed to the first method. Can you guess how you'd append a method to construct a chain? Just like any other addition, you can use plus equals. When you write chain plus equals followed by another method, it will now change what the chain variable points to, and it will be a multicast delegate where you have a chain of 2 methods. It uses the same delegate type, process completed. To anyone that expects this delegate, it looks and acts just like any other delegate that you are using. The consumer of the delegate does not have to care or do anything differently to execute all the methods in the chain. Once the delegate is invoked, it will automatically run all the methods in this chain, sequentially that is. This means one method will be executed after the other. It won't do any parallelism for you. Append the second and third method to the chain and pass this to the process call. If you execute the application, you should see the execution order. It'll start by executing the first, then the second, and then the third. You've successfully introduced a chain of method calls using a delegate. There's one thing I'd like you to keep in mind. Remember earlier where we talked about the drawbacks of using a publicly exposed delegate? If you can simply append more methods to a chain like this, a publicly exposed delegate could have methods appended to it from multiple different places. Just as it's easy to add methods, you can also remove method references from the chain. Again, if it would have been a publicly exposed property, anyone could have modified the chain. To remove a method from the chain, let's say the second method, can you guess what you write? You simply subtract with that method. This will remove the delegate from the invocation list. After the subtraction, we'll call process again, then run the application. This should now show you 2 results from calling process, where the second one has 1 less method invoked through the delegate. You may be wondering now what happens if you try to add the same method multiple times, or even remove a method that doesn't exist in the invocation list. How about we change all the methods in the chain to point to method 1? Then, after the first call to process, where we remove one method from the chain, let's keep that code that removes the method 2 from the chain, and then also remove method 1 from the invocation list. Before running the application, do you think that the first method will be executed once? And what do you think happens when you subtract the method 2 from the list of delegates? Let's run the application to find out. First of all, it added and executed the methods 3 times. This is exactly what we've indicated in the code. I'm really happy that the application didn't get any exceptions or issues when trying to change the chain to remove a method that was not in the invocation list on the delegate. What's also interesting and good is that when you subtract the method, it only removed a single occurrence. If you had wanted to remove all of them, you'd have to subtract the method 3 times. When constructing the chain, you may notice that you cannot simply do it in a single line. If you were to construct a processed completed delegate chain and write 1 + 2 + 3, this will give us an error. You can only append a reference to a method when the left-hand side is a delegate. To get around this, you could cast the method reference to a delegate and append all the methods you'd like after that. This is just another way of constructing the chain. With an understanding of delegates, how a delegate is constructed and invoked, you are now ready to move on and look at lambdas, as well as the action and func classes.